Good morning, everyone. Welcome to the webinar from TriStar. My name is Thiagu Palaniappan. Those who are not familiar with TriStar, we are a company that specializes in helping manufacturing companies adopt software systems and processes to enable better and more efficient product development. Today's topic for the webinar is going to be, just introducing and doing an overview on the new Creo ANSYS simulation product that was just introduced by PTC about a month ago. They released Creo 7.0.2.0, the latest date code of Creo, and that has a new, high fidelity, more accurate ANSYS-powered simulation inside of Creo, fully integrated. So I want to just go over that. Real quick about our company, we have been in business for over 25 years now. We have done a lot of PLM implementations, and we do have experts in CAD, FEA, data management, and product development. We are the largest resellers worldwide for PTC products. We are headquartered out of Phoenix in Arizona, and we do have our teams spread across the United States, as well as Canada and Mexico. I'm based out of the Chicago region here. From an agenda standpoint, before we talk about the agenda, I thought I should quickly go over some of the time-limited offers that we are running through this end of this month. It's also simulation-based, so there's 33% off on Creo Simulation Live, the Creo ANSYS simulation, the new thing which we're going to talk about, as well as the Creo Simulation, the old Creo Simulate and Advanced Simulate extensions. So if you're interested or if you would like to know more about this, please reach out to your account reps or visit tristar.com to know more information about these time-limited offers. I just wanted to go over the first little bit of a high-level overview on the computer-aided engineering tools inside of Creo, right? Just kind of giving you a CAE landscape in Creo. As many of us know, Creo's very popular CAD system, and PTC also has the Windchill PLM system. However, they are also very good at the engineering, computer-aided engineering side with several tools. So I want to just give you a quick overview on that. At the same time, focus more on the Creo Ansys Partnership, wherein they start off with Creo Simulation Live 2 years ago. That was the first product they integrated into Creo, GPU-based, quick, feedback, instant, real-time simulation. But our customers sometimes also wanted to have a high fidelity, more of a mesh control, and a little more of a higher end analysis tool. And for that, in Creo 7.0.2.0, it was just released a month ago. The latest date code of Creo 7 has this product called Creo ANSYS Simulation. It's licensed, it's a separate add-on extension, but it's fully integrated. So you get the power of ANSYS Solver right within Creo. So we'll talk about the capabilities, go through some comparison charts, and also demonstrate some of the examples, parts and assemblies it works, and how does it, how the overall big picture of these Creo ANSYS product, how does it help both the design engineer and the higher end analyst that might want to do, higher end analysis. It could even be the engineer or the designer that wants to do some quick upfront what if scenarios and get some quick feedback, but before the final validation, you may want to use a higher end tool. So we'll go through that with some demonstrations, and towards the end, we'll also go through a Q&A session. Feel free to start typing in your questions in the questions area of the webinar. There's also a handout section. Feel free to download that PDF. It's about what's new in Creo 7.0.2.0. There are a couple of new technologies they introduced in 7.0.2.0. This is the one, this is on the Creo ANSYS product. There's also another thing on the generative design, which we will cover in a separate webinar later. So with that said, let's jump into the main thing. First of all, many of you may have used some of these tools. Some of you may or may not have used these, but what you're seeing here is pretty much the computer-aided engineering landscape in Creo, over several years, right from the old Pro Engineer days to current Creo 7, PTC has had quite a few analysis tools, right? So whether it is MathCAD-based worksheets to control your Creo parameters and dimensions, or it's tolerance analysis, or it could be behavioral modeler extension for design optimization, or mechanism dynamics, right? When you have kinematics and mechanisms in your assemblies, or for animation, there are several tools here, as you can see. And I want to focus more on this area in the top right corner here, the PTC Ansys Partnership in this presentation. They've also been adding, newer simulation tools, right? So many of you may have or used the old Pro Mechanica, now called Creo Simulate, right? So it has very powerful. It has a basic and advanced license, depending on are you doing linear or nonlinear analysis. And now they are adding to that simulation product line a few more, like Creo Simulation Live with Ansys Partnership, which is essentially Ansys discovery engine working instead of Creo. And now they also have Creo Ansys Simulation. So there are a couple of products to talk about here. We already did a webinar specifically on Creo Simulation Live. Some of you may have attended it. I'll just do a quick overview on that, but mainly we'll focus on the Ansys simulation here. So the goal here to have so much, a wide variety of products, is to kind of give you that scaling, right? So for example, some of you may be designers, engineers that do not have any FEA background. Some of you might be experts, or some of you might be somewhere in between. So, and you do need tools that are quick and easy to use, and you shouldn't be waiting for results for a long time during the initial stages. But as you get into the final validation stage, wherein you won't be doing a lot of design changes, at that time, you want a high fidelity solution, right? That's kind of why PTC has this Creo ANSYS simulation, as well as the Creo Live simulation, right? Which is GPU based. ANSYS simulation is traditional CPU based. So there are different, we'll go through some capabilities and things like that, but this just to give you an overview on the current CAE landscape inside of the PTC product line that are fully integrated into Creo, right? You're not importing, exporting anything. Even for fluid flow, if you want to have a higher end solution, you got Creo flow analysis that is powered by Cimerix. Then you got Creo in Creo Simulation Live, you got some basic fluids powered by ANSYS. So really some exciting additions of late by PTC. The last couple of years is when this ANSYS partnership has become stronger and stronger. And as we all know, ANSYS has been there for a long time. It's more like the best of the two industry leaders, right? PTC has been in business for nearly 30 years in the CAD and PLM world, and then ANSYS close to 45, 50, so 50 years there. So it's the goal of this partnership is to remove the barriers between the CAD and computer-aided engineering, right? Just to make sure that we are giving the ANSYS proven technology, the solver, we all know the flagship products of ANSYS that many customers use. So we want to make sure that every design engineer using Creo, for designing, gets that or is able to leverage that ANSYS product. And for that, there are a couple of, two options really. One during the initial stages and one just before for the final validation, right? That's why it's two products have been included now, So and this partnership is obviously going to grow as we hear from PTC, with more and more to come in Creo 8 and 9 in the future, with more and more enhancements to the capabilities of these two. But this is these are the two products, and when I say two products, I'm talking about live simulation, right? It's completely GPU based, instant feedback, right? You don't have to be an expert to use it. And then sometimes some of you may be more FEA experienced, or maybe may have used ANSYS Mechanical, or would like to have a higher fidelity solution there, right? You may have used other higher end tools. For them, ANSYS Simulation is the second product that they have integrated now, or that's kind of, we have two extensions there. So really, two industry leaders coming together to make sure they give highly accurate instant feedback type simulations from Ansys right inside of Creo without the need to import, export, or still able to leverage PTC's own robust editing and modeling environment, right? That's the best thing about this, right? So what are the two tools that I keep mentioning? One is Creo Simulation Live. Some of you may have already seen it, or I've already done a webinar on it. You could look up in our webinar recording at TriStar.com or in our YouTube channel. I just specifically did one on Creo Simulation Live. Now that's been there for close to, I'd say, a year and a half, or I'd say 2 years now, starting Creo 4 MO90 date code, and later Creo Simulation Live is supported, right? It's called CSL, or it's Creo Simulation Live. It's completely GPU based. And as they say there, it's instantaneous feedback. It's more of a directional tool, right? May not be very, very accurate in there, but during our initial, design state where you're just trying out things, you're in an ideation or exploration stage, you don't want a high fidelity solution at that point. You just want some guidance. Okay, should I be using this geometry versus this geometry? Should I be adding more ribs to my design? What should I be doing? That initial help where you don't have to go to an analyst and wait for him to give you results. That's that Creo Simulation Live, right? And then just a month ago, Creo 7020, right? It's technically the second date code of Creo 7.0, MO20, technically now called as 7020. That was released, and with that, PTC introduced this Creo ANSYS simulation, right? So what the ANSYS simulation is meant to do is to give you more of a high fidelity, higher accurate solution. This is more traditional finite element analysis with CPU, and it's not leveraging GPU. It could use for results, but it's just typical CPU use, CPU based, mesh based, because Creo Simulation Live doesn't even have the mesh. It's all happening behind the scenes. It's leveraging the graphics card's GPU, right? Creo ANSYS simulation is more, you can control the mesh, you can refine it, things like that, where you can do some linear contacts. You can apply joins. It's some of you may have heard of Ansys AIM product. It's pretty much that one that's embedded in here, fully working natively inside of Creo, right? So you got two options really. One for initial direction and guidance, which is Creo Simulation Live, and then for just before your final validation, where you expect that there's no more drastic design changes that's going to happen in your design, but you still need to validate it using a proven tool like Ansys. That's when Creo ANSYS simulation comes into use, right? So there are two options here, and this webinar will focus more on the Creo ANSYS simulation, but some of you may not have heard of Creo Simulation Live, so I just wanted to kind of give you a quick background on that. So really, PTC's integrated Ansys discovery simulation engine instead of Creo, and the biggest advantage is quick real-time analysis or feedback in seconds. You don't even have a run button in Creo Simulation Live. You set up your loads, constraints, you apply materials, and then you just say show results, and it's that quick. So you can essentially go to your modeling environment, make changes, and in real time it gives you results or a feedback. So what is it? How does it do that, right? I mean, yeah, there is proprietary Ansys technology working behind the scenes. You don't get to see the mesh, etc., but it's leveraging the GPU of your graphics card. So there is a big requirement for CUDA-based NVIDIA graphics card, and PTC.com has those requirements in their website or the hardware side on Creo Simulation Live. That's Creo Simulation Live, right? It has static structural analysis, thermal model, and even basic fluid flows starting Creo 7, right? That is Creo Simulation Live. Now, as for Creo ANSYS simulation, that's more high fidelity structural, thermal, and modal analysis, right? And this is going to be continued to be improved in Creo 8 and 9 and beyond. But right now, I'll kind of show you what we have as of Creo 7020. This is, traditional, typical, CPU-based technology, right? Which uses, you can go and control the mesh. It's typically that most FEA tools are, mesh-based, and it's not using GPU other than Creo Simulation Live or Ansys Discovery Live, right? So that's what this Creo ANSYS Simulation is. So again, just to kind of recap that, Creo Simulation Live uses GPU, and it's available starting Creo 4, right? So if you're on Creo 4, 5, 6, or 7, if you have that license of Creo Simulation Live, you should be able to get that quick feedback and to give you that initial guidance and instant feedback without having to do any type of pre-processing that you would normally do in a simulation tool, right? That's Creo Simulation Live. It's been there for over nearly 2 years now, okay? And what we are introducing, or PTC is introducing with Creo 7.0.2.0 is Creo ANSYS Simulation, right? So that's just to make sure the naming is there, Creo ANSYS Simulation and Creo Simulation Live, right? Creo ANSYS Simulation is the new one. And as you can see, it's inside of Creo Parametric. You can see your familiar ribbon interface. You would just select Creo ANSYS Simulation, and once you enter in, you're able to define structural, thermal, or modal analysis. You can control the mesh, right? It helps both new users and experienced users. For example, it has physics-aware meshing built in. So depending on the physics you define, it understands to set up certain rule parameters for those mesh refinement, right? And manually, now let's say you're saying that you're very experienced in this and you know where you need to refine the mesh based on your experience. You can always do that as well. So they kind of give you both options there, right? There's even a little slider to just set it to faster simulation, but less accurate, but longer simulation, but more accurate, things like that, right? So, or you can do your own manual control on specific areas of the geometry, right, on both parts and assemblies, right? And if you have already defined an analysis in Creo Simulate or Creo Simulation Live, you're able to bring that setup into Creo ANSYS Simulation. There's an import study option, so maybe you've done some initial what-if scenarios using that GPU-based quick directional tool, and now for the final validation, you don't have to do all the setup from Creo Simulation Live. It picks up all those loads, constraints in your setup, and you just have to pretty much run the analysis inside of Creo ANSYS, right? When you get into larger assemblies and complex geometry, as you know, some of you may be aware of idealizations in FEA that we use. Idealizations are mathematical approximations, right? I might have a huge engine or a huge assembly that sits on a mount frame or something, and I'm interested in that. I'm not really interested in analyzing the huge assembly. I'm able to mimic that as a data point, and maybe I could just set that as a mass element. Or if I have sheet metal parts or thin geometry like ribs, I might just want to do that as a shell idealization. So it makes computationally, it'll be less expensive, right? That's the whole goal of that. Similarly, I might have components where I might want to mimic that or approximate that as a beam element rather than a typical hexahedral mesh with solid idealization. So those are all supported inside of Creo ANSYS Simulation. So you can see why it's more of a high fidelity simulation tool compared to Creo Simulation Live there, where it doesn't support these, right? And as always, you have the ANSYS solver, right? It's using the same solver that ANSYS Mechanical and ANSYS Discovery, they all use. So you do have that golden standard of ANSYS solutions that's built in there. With the ability of the user to either use the default mesh or control the mesh manually, right? And you can even go and say, okay, so now that I've done with Creo ANSYS and maybe I want to do some more higher end analysis further than what Creo ANSYS allows inside of ANSYS Mechanical, you can even export to that, right? So that's really kind of just to give you a quick intro on what is Creo ANSYS Simulation here. And if I could, before I show you some demonstrations, just to quickly run through some capabilities real quick here. Constraint-wise, you have your typical fixed constraint. You can apply enforced deflection, for example. You have planar cylindrical ball and frictionless, for example. You don't want the geometry to to move normal to the surface itself, normal to itself. However, it can slide, for example. That would be a frictionless support, right? Same thing with loads. You have your typical force, pressure, centrifugal load, temperature load, right? Linear acceleration, and and you can change the unit system and things like that. Pretty normal and typical that you would expect in any simulation tool or CAD embedded simulation tool these days, right? You could also apply loads and constraints at a point, very useful in larger assemblies where I do know mathematically where the load is applied, but I don't want to include that interfacing geometry. I could say I want to apply it at this remote point, but distribute at these surfaces through which the load is getting transferred. So it's a pretty powerful tool, all those, right? So the goal is to try to, giving you all the tools to make sure that you are applying the boundary conditions and mimicking the real world boundary condition to the as best as you can inside of Creo ANSYS simulation, right? And then thermal boundary conditions, you have steady state thermal as of now. Not transient thermal is not yet available, but that's something maybe in the future. But right now with 7.0.2.0, remember this is the first initial release of Creo 7, date code 7.0.2.0, that the Creo ANSYS is there, and so you might see more and more enhancements coming up in the future. But you can apply temperature, convection boundary conditions, radiation, right? You can apply an emissivity, right? A few things are not supported, surface radiation, but those might happen in the future. But just to give you an idea of thermal, basic steady state thermal simulation could also be done inside of Creo ANSYS simulation. The meshing, like I told you, this is a high fidelity simulation tool, so it obviously needs some very good meshing controls. So by default, it is physics aware. So depending on the geometry and depending on what type of analysis you're defining, it understands to control the mesh automatically, and there are some default settings that you could change, or if you're a new user, you could just use a slider to refine the mesh, or sometimes it's a good trade-off in there. You want to sit in the middle, or you want to go a little faster. I want to get a quick solution. You could change all that, but by default, the mesh itself, it uses hexahedron, excuse me, mesh in there, and you can go control, for example, the included angle, the element size. There are so many additional controls for an experienced user that would want to have a higher mesh in specific areas to reduce the stress error. You're able to do all that inside of Creo ANSYS simulation and preview the mesh and even look at the results with the mesh, right? That's something Creo Simulation Live didn't have, because the use case for that was more directional, and it was really meant for quick upfront, simulation-driven design where you're not even done with your geometry yet, but you want to get some guidance as you are in the process of creating your geometry. Now that you're done with your geometry, now I would like to get a high fidelity, accurate answer, and that's when these meshing techniques would come inside of Creo ANSYS, right? Like I said, idealizations, like you could use spring idealizations, beam idealizations, as you can see here, right? These are, I've just created some beam elements here. Here I have a spring idealization, wherein I could specify the stiffness. It could be a 1D or a 3D spring. You can give torsional and longitudinal. So all those are available in many of the traditional FEA tools, and we want to make sure that it's there inside of Creo, inside of the Creo ANSYS a suite of products, where many of these are in Discovery Live, and it's just embedded inside of Creo now, and it's just the usability of Creo, the interface that you're used to, and the power of ANSYS, right? That's kind of what you get in here. When it comes to assemblies, as you all know, connections is very important, right? I would like to know when two surfaces are touching or where there's a gap, how to handle that. So currently, there's a way to specify a contact. It can be either done manually, or when you bring in your large assembly into Creo ANSYS, there is an automatic detection too, where it can automatically pick it up as bonded or no separation, for example, right? Nonlinear contacts are not yet supported, maybe in the future, but for now, bonded or no separation. And you can also control or control the degrees of freedom by controlling the behavior of two geometries from two different bodies or components, right? You could specify a joint and say it's going to be a fix, it's going to be a hinge, where it can only rotate in one direction, but translation and rotation, fixed in the other direction. There are quite a few joint behavior things. You can even create your own degrees of freedom when it comes to two geometries. Very useful. Instead of using, like weighted link or rigid link that some of you who may have used Creo Simulate or Advanced Simulate, this is kind of a little more powerful than that. We are able to control that joint behavior, right? And then finally, results. As always, results are important both for reporting purposes as well as for you to interrogate the model and see in an assembly, look at the stress plot, deflection plot, look at specific geometry of interest with the mesh, without the mesh, look at the animation. Is it kind of deflecting the way I would have expected in the real world, right? You have all those different types of plots, right? Whether it's vector plots to know both direction and magnitude, or it's just contour plots. You could also use a results template to automate the creation of the results, right? You could just create an XML file and have a specific set of results that you're always interested in, like here, right? These are the specific ones that I'm interested. There's like basic and advanced. With basic, you cannot do a few things. With advanced results, you'll be able to do some animation and create some, additional probes could be added. So a couple of options there, but overall, it should help you once the analysis completes. You're able to view the results, and if required, you can go back, make the change, rerun the analysis, update the results, and you're able to see it, right? So you can also create your own probes, specific probes that you may be interested in certain areas of the geometry, okay? So really, if you let me just kind of pause here for a little bit. We introduce you to the new product here, and many of you, a common question that I get, or at least many of the customers have asked, okay, what is currently PTC's simulation portfolio, right? I showed you the computer-aided engineering landscape in my very first slide, but this is what it used to be 2 years ago, right? Wherein we had PTC had Creo Simulate and Creo Simulate Advanced. There are two extensions, and though some of our customers who just need linear analysis, they would use Creo Simulate, and those who required advanced nonlinear analysis, large deformation, contact, or even shaker table tests mimicking like vibration analysis. They want to bring in a PSD plot and do some vibration high-end analysis there, or time, they want to do a half sine sweep test or a shock analysis. Those type of things are available in Creo Simulate Advanced, right? So that those used to be the two options we used to have, and we had a fatigue advisor to do some fatigue analysis as well. Now, over the last 2 years and all the way till right now, PTC has been adding more to that portfolio, as you can see here, right? The additional 4 options here: Creo Simulation Live, Creo ANSYS Simulation, Creo Flow Analysis, and the generative topology optimization, right? So a couple of them are just recently done in Creo 7, I know, but Creo Simulation Live and Creo ANSYS Simulation, both of these are powered by ANSYS, right? So one is real-time solution, right? The other is high fidelity with giving you mesh control and some additional options like joins and contact definition, things like that, right? So those are the 2 options. So really, you got a wide variety of solutions to choose from, and depending obviously on your requirements, this will help, right? We got basic tools, as well as it's something that the designer should be able to use without no training or absolutely no experience in FEA, and also tools that he could use with a little bit of training or some. If he's an expert, or use other FEA tools. That's the goal here, right? Giving you, as your design progresses through the design process, you might need a different tool when it's at just before releasing, versus in the initial stages where you do a lot of what if scenarios. You keep changing. You're in your ideation stage, or I would say design exploration stage. You need more of Creo Simulation Live, right? So, and if I to give you a very high level quick capability comparison, or all these are on TriStar.com and PTC.com. You can go look up our the product pages, and it'll have some comparisons there. You can see I've put in the slides here essentially show you Creo Simulation Live and Creo ANSYS Simulation. These are the ANSYS products, right? These in here, these columns, and these two are the old Mechanica and Advanced Mechanica, are now called Creo Simulate and Creo Advanced Simulation, right? So you could see the comparisons there. There are a few things. There's obviously certain things that Creo ANSYS has that Creo Simulate may not have, or Creo Simulate has that ANSYS doesn't have, but just kind of gives you an idea. And this might change in the future, where more and more capabilities will likely be added in the ANSYS side of things. And Creo Simulate is still a good product, and it's continued to be maintained by PTC, and that's still there. But it's nice to have these additional options now for our customers, right? So, okay, so with that, maybe I just wanted to give you a quick idea in here about the interface itself. If I just let me run this video here first, and then I'll do my demonstration. This is just in Creo 7.0.2.0. You could see how I have a bike frame assembly, right, where this is Creo ANSYS, right, right inside of Creo Parametric, and it is quite a lot of setup here. As you can see, I'm looking at the stress plot here with animation, but for the suspension, I might have used spring idealization. I'm allowing it to slide, for example. Now I'm looking at the deflection here, right? I'm controlling the speed of the animation here. But to do such kind of high fidelity or complex geometry analysis, you would need a higher end tool, and that's what Creo ANSYS is about, right? Just to give you an idea, even though the demo I'm going to be doing, I might show you parts in the interest of time, it can really work on larger assemblies also, right? So here I'm just looking at specific, I'm scoping out and looking at the frame alone instead of the entire geometry, right? Looking at the stress profile just in that frame, so I can add different types of results. There's even config.pro options to automatically create multiple advanced and basic result types. Here I'm going to look at the deflection plot of that frame assembly. So this is something where I've used idealizations, I've used loads for the person sitting on it, for the fuel tank, maybe for the engine. The engine itself is not there, or I could just use a mass element and distribute the force. So I've used all types of capabilities that we would see in a higher end tool inside of this tool in this assembly. And I just, I just thought of just quickly running this before I do a live demo, just so that you understand like what it's capable of with this with an assembly and with all the complexity that would come in an assembly like this, right? So maybe to mimic the stiffness or the suspension, maybe I might want to apply a spring element. And so right in here, as you can see, I might have a spring elements on here, right? I have my loads applied in here. I've constrained it. I would add some joints between these different components. Maybe I might want to just take a subset of this large assembly and then run it separately. So all that can be done, and inside of Creo Parametric 7, as you can see, 7.0.2.0, you have ANSYS simulation, and it looks very familiar with your user interface, right? Your loads and constraints, your material properties, your results, right? And additional options. You have your typical model tree with your setup, everything there, right? So, okay, so with that said, let me just go to Creo real quick and show you some examples. We'll take the remaining time we have here. We'll go through some quick examples here. So, for example, I'm going to go. I'll start with some of you may not have seen Creo Simulation Live, so I'll start with that just to kind of give you a workflow of where we see customers using both these tools, for example, right? So I'm going to start with very basic one in here. Let me just open up one of my assemblies here. It works both on parts and assemblies, but in the interest of time here, I didn't want to just wait in the demo for meshing and running results. I'll just show a quick part first. So in here, let's say that I'm taking the role of an engineer who does not have FE experience. Let's say I'm primarily I do design, and the goal, my goal here, or is to create that support plate or bracket or what have you. On this mount geometry, I need to create this part, and I'm still in the process of creating it. I'm going to activate that in Creo. As you can see, I'm just in my regular assembly mode. I activated a part in here, and I'm creating some geometry. I'm going to create some geometries here. I already have, just to help with the demo, some sketches done. I have 4 shapes I'm exploring, right? I'm not yet sure which one I'll use. For example, I hit X in my keyboard, and I invoke the extrude tool. And I'm going to go, I'm just using all the new usability enhancements of Creo, right? The keyboard shortcuts and things like that. I just shift select. I just snap to this guy here. I'm going to go to side 2. Maybe I'm going to just go hold shift, snap to that. Just a simple up to surface design, and that looks good to me. Very simple, but I've not yet completed this design in any way, right? I've not done any radius. I've not added my mounting holes, nothing. I'm just still in the process, in my initial design phase here, right? In my process. So if I go and say, okay, you know what? I probably don't want that. I'm thinking maybe I should be using this guy instead, right? Or I'm thinking, okay, would this work? Or I'm just saying, okay, maybe this geometry, this is what I think that connection between those two geometries should look like. Or maybe I'm just doing a quick edit definition. I'm using multiple external sketches, as you can see here, right? There it goes. Maybe this is what I should use. So now, typically, normally what you would do when you go with that or this, you either do like a rough hand calculation, or maybe you send it to an analyst if you're not the expert, and have him give you some guidance. So that's what I'm looking forward to, a quick tool that gives me initial feedback as I make this change, right, that I just showed you. Let's say I want to go back to that original shape that I have the sketch 1 that I have here. And when I'm in this geometry, I'd like to get some feedback. So I'm going to open that in a separate window here. And the 2 tools that I was talking about, right? One is this live simulation, right? That's been there for 2 years, right? Creo Simulation Live. It's GPU based. I'll show you that first. And then the other one is, if I go to applications, the new tool is Ansys Simulation, right? I want to kind of show both, actually. So in this demo, so when I go to live simulation, all the system is doing is it's loading my Ansys libraries, and it's kind of really loading. You can see that Creo Simulation Live libraries is getting loaded right now. Maybe I've not accessed it today, and it's just accessing it. There it is, right? And it's loaded in there. So this is the GPU based one I was talking about, right? So maybe I want to quickly apply a load in here. Maybe you want to go direction. I'm looking at my triad in here. The y-axis going up. So maybe I'll just give it a negative 100 pounds. For example, I probably want to fix this guy here at the bottom, right? There it goes, right? So I've done a very simple one in here, and already it has PT Creo's material, right? There's steel applied and everything. That's it. I don't even have a run button, as you can see here, because I'm not the analyst here. I'm looking for some direction about stress and deflection. That's pretty much what I'm looking for. And I don't want to refine the mesh, run the mesh, etc. I just want to, so I hit this little simulate on. So what it's doing right now is it's going to give me it's going to leverage my graphics card's GPU. I have an NVIDIA graphics card with a video card, the video RAM is 4 GB, right? PTC recommends 8 GB, I have 4 GB. And the RAM in my computer itself is 32 gig, but the key is, how was it able to just give me results that quick? It's using that Ansys Discovery Live behind the scenes, and it's able to give you that. I can look at my animation. So this is not Ansys, Creo ANSYS. This is Creo Live Simulation, which is also powered by Ansys, but it's for that quick instant feedback. That's pretty much it, what it's giving you, right? So for example, if I look at the stress plot here, it's telling me it's 15 megapascal here, and I don't even have to get out of the simulation tool. See, I'm in my modeling or my typical PTC design environment here, and I'm still seeing the results, I can go back to this design, redefine that, and say, let's use this guy instead. And as soon as I switch the geometry, I'm not having to go back, hit run, rerun the analysis or anything. It's immediately, almost a couple of seconds it took there, it's giving me a feedback telling, if you use this shape, the stress is going to go up 59 megapascal, right? Now I'm going to go back here, redefine it, and I'm going to say, let's use this one instead, right? And it's kind of giving me some real-time feedback, as you can see here. I'm just letting it, yeah, there it is, right? It's pretty quick in there. It says, yeah, that's brought it down to 17 again. Initially, we start off at 15 megapascal, if you remember, or you can also check it in PSI, whatever unit system you're comfortable with. I'm looking at this design. So I'm doing my day-to-day editing and modeling activities, and this tool is there guiding me through and letting me know this will work or this will not work, kind of a thing, right? I'm in real time. It says that's huge, that's 57, that's not good. So I'm just saying, you know what, I'm just going to go back to my original shape that we had started with. That looked pretty the least. The stress on that looked the least. I still have to add some fillets and things like that, but looks like I have a good start here, right? That's really what I have here, as you can see, right? 15. Now, how can I improve this further? Because if I go look at my little max minimum, it's showing, okay, there's a max stress there, right? It kind of highlights that for me. So I'm going to just add a fillet in here. I'm just going to go use my Creo design tools now, right? As soon as I start creating the round, that color goes away. Once I'm done with it, middle clicking out of it, it kicks back in. And it's telling me, there it is, right? Okay, it's telling me that the stress, it's recalculating with this new geometry right now. It just took another 2 or 3 seconds, and it's telling me I brought it down a little bit, but didn't help much. That maybe I can increase the radius and things like that. And I'm thinking maybe I got to go, do some things in here too. Maybe I want to add a chamfer or something like this in here. Maybe using all my usability tools in Creo. Maybe like I said, the best of the design world and the best of the analysis world working together to give you, quick solution from Ansys. It's Ansys powered, but instead of Creo, right? That's really what you're getting here. Looks like that didn't bring it down too much, but I'm thinking, at this point, maybe let's do some ribs in here. So maybe I want to add a rib feature right on this plane. We'll just say we'll maybe help. That might help a little bit with relieving the stress. I'm thinking. Let's just go add something like that. So maybe I'm just doing a simple sketch, and we'll just give it a specific thickness. I'm done. As soon as I'm done with it, there comes in Creo Simulation Live, right? It's kind of giving me some live feedback, and that's the instantaneous feedback that I was talking about. Looks like I still didn't create a round, so it's still increased in there. So I'm thinking maybe let's add a few more ribs. Let's do a quick pattern in here, right? So all of you know, we've used Creo for a while. You could do like different types of patterns. They're all in the mini toolbar right now, direction pattern. And maybe I can just go use that as a reference. And I'm gonna say, let's create about 3 of them, just give it some distance here, roughly. There it is. Now, once I'm done with that pattern, I see how the what if scenarios is never used to be like this in any other analysis tool, right? We always have to make some changes, rerun the analysis. That's kind of why this is meant for that designer to use it during the initial stages, right? That's what it is. 8.6 from 15, we got it down. We got a good factor of safety. Now it came to 8 megapascal here. I could further improve it. Maybe I could just do a little edit and maybe add more weight, or maybe just make it a little more so that when it deflects, it doesn't deflect as much. In here, we're adding a little more stiffness in that region, as you can see. So this is all that you would normally do and go back and send to an analyst, and then, or there may or may not be an expert in the company, but you at least have some guidance here, right? So that's what, and we brought it down to like 4 megapascal here. Now, at this point of time, I'm thinking, so yeah, this is kind of what will work, right? I'm probably can start using this in my design, and I could probably do the same thing on an entire assembly, right? I could just go and say, this should be mirrored, right? I could just mirror this component, off of my right datum plane, for example, right? I do a little preview here. It comes up, as you can see here on the other side, and it's looking good. And I can even do the same thing on an entire assembly, right? On entire assembly also, I could do simulation live. It works on entire assembly too. But before finalizing on this, I'd like to have this part analyzed in a higher fidelity solution, right? I was not able to see the mesh. I couldn't see anything. All I saw was results. So I'm able to go to applications, and this is the new one that they introduced in 7.2.0, the Ansys simulation, right? If I go to Ansys simulation, what it's able to do is all my setup in live simulation is brought in automatically. You see my loads, my constraints. But here you could see you got a lot more control. You got idealizations, contacts, joints, mesh control, surface regions. That's kind of why it's a higher end tool, as you can see, right? Now, for example, if I want to do my mesh, I could just go say generate the mesh on this and see the mesh. Now, what it's doing right now is inside of Creo Parametric, you could see this little icon right here at the bottom. It's running the process. If you see the process right there, if I open the process manager, it's really literally telling me that the mesh is in progress, right? It's using the Ansys mesher, and I've not yet solved it. I've just created the mesh, as you can see here, right? While it's doing it on a large assembly or a component, you could even go back and do your regular day-to-day Creo work, right? It's not that you have to wait for it. You can just there is no way to even erase it because the process is still running, right? That's a good thing about it, right? You can multitask is what I mean. Once it's done, now I can go back and say, display the mesh, and there's your traditional hexahedral Ansys mesh. Maybe I can go refine it. I can go refine model, and I have some options here under mesh control. Global sizing, I could say, is it based on curvature or proximity, or should it be fixed? Should it be neither, right? I can control all that. Or if you're not an experienced user, you could just say, okay, from low to high or somewhere in the middle. It's a trade-off between accuracy versus how quick it's going to run, right? That type of a thing, right? For mesh resolution, you can do that. But the idea is once you're done with something like this, you just run the analysis, right? You just say, I want to run the analysis. And what it's doing right now is using the Ansys solver, right? As you can see, the mesh is done and it's solving it right now, right? It's solving, it's 10% done right now. And at this point of time, I can still, let it run. I'm not, see that it's still running in there. I can go back and I can refine, I can look at other things, or I can even open a different model and work on that. So it's not that I'm kind of stuck in Creo without able to do anything. It's just that it's telling you there is a background process that's running. It looks like it is also solved. It's just populating some results in there. That's why I took a simple part here so I can quickly show it to you in real time. The assembly that I showed you, that obviously takes more time to run and solve, etc. It's using traditional CPU-based computing instead of GPU. So it does take its time. There's looks like the results are almost done here, right? You can look at the diagnostics. If you look at this and go to the diagnostics, it has your Ansys reporting. You can control where this gets created and all that, but you get the idea. It gives you, it'll have the number of elements, information about the solver, everything, right? Now I should be able to just go look at the results, and I have my basic results that are automatically populated there. I have my von Mises stress, right? I could also go do a little query here and say, okay, what is a result here? What is a result here? So I'm able to query to the area of interest, or look at deflection plots, right? Look at different options, or I can just create my own, right? I could just say, let's add a contour plot. And is it going to be on the entire geometry or specific parts? Or I could create my own. For example, here, I want to go look at von Mises stress this time. And also I want to add a few more contour plots here, but this time I'm going to go other. And you can add your own multiple result types. You can see, you can go look for reactions, different stress components, right? Element volume, structural error, right? Things like that. You can add multiple different options there. But my point here is, see, when I did the new results, it's telling I need to update the results because I've added a few things here. I can just go quickly update those results. I'm not rerunning it. I'm just adding some advanced results that kind of gives me some additional options, like showing the mesh with the results or doing the animation, things like that, right? The basic results are out of the box. Advanced also can be turned on with some config options. But so now I can just say, let's activate that, and then let's do a little analysis, or I should say animation here, maybe increase the speed in there. It kind of gives you the animation, and also I can turn on my mesh, and maybe I don't like that mesh. I can go back, refine the mesh, etc. Right? So I could always do that. So there's so just to kind of giving you the workflow with this part. I hope you understand this, both quick upfront real time as well as higher end high fidelity solution, right? That's kind of what I showed you so far. Now just to open up a few other things that I've already done real quick in the last few minutes we have here. If I open up a much larger assembly, for example, I might have, I mean, not a larger assembly, but multiple parts here. You can see my exploded view. Got about 4 parts in here, pretty straightforward component. How do you want Creo ANSYS to have these interfaces defined, right? So again, as soon as I go into applications, ANSYS simulation, this is kind of what will happen. It's going to give you the option to either go structural, thermal, or modal. So remember physics aware meshing. So depending on the physics I select that structure, and I could do automatic contact detection, or I can do it manually. And that's it. When I'm in here and I look at my contacts, and there's, like, as you can see, 4 bonded contacts in there. So I can go back, redefine each one of those contacts. I can either set to no separation, right, or bonded. As you can see, nonlinear contacts will happen in the future, but just to kind of show you some of the other tools in here. If I go to another assembly, if I open up, let's see here, maybe a steering joint assembly like this, where you could see the way it was done, right? You got a 1/2, then you got the part in here. So in this case, I'm interested in the degrees of freedom between these 2 parts, right? One could be stationary, the other could be mobile, right? How do you allow it to move? So that's when the joints comes into play. So if I go into applications and go ANSYS simulation, I already have, as you can see here, 100 foot-pound torque applied in here, right? Moment load is what I've applied. Applied a frictionless support here, so it can slide, but it cannot go normal, etc. Right? So that's so all those are under here, right? Support. You can go planar, cylinder, etc. And then you have your joints. So here I've already created these joints, but typically what you would do, so if you look at the joint, so you go to your refine model and you do your joint, you're able to set the joint as fixed, hinge, translational, slot, even create your own, right? I can even create my own and control translation and rotation, etc. Right? So currently, if you see my hinge, I've just created a hinge on these 2 cylinders. All 4 cylinders, I have a hinge in there. And then I would do a mesh, right? I can go back and say, let's go show the, generate the mesh in here. And while it's working on it, like I said, you could, in the real world, it's not like you're waiting on it, right? That part is already, that assembly is in session, and you cannot erase it since there is a process that's using it, as you can see here, right? It is doing its mesh as we speak here, and it's yeah, it'll let you know once it's done, etc., and you can refine the mesh, etc. But while it's doing it, let me see if there's any questions in the questions area. Let me see here. Okay, so the first question: would you recommend 3 books for FEA that one can learn in the next 5 years in advanced knowledge? I do not mean FEA theory, but those that can make me in a few years take full advantage of Creo. Okay, that's a great question. So yeah, I see what you mean. It's more than theory. You want some information about how to start using the simulation tools instead of Creo, right? It could be Creo Simulate, it could be Creo Ansys Simulation. So the first thing I would recommend is obviously there's there are a lot of training options, learn online options these days with e-learning. If you have e-learning, I would just go do that, or if you have tutorials, I would go use that too. There's a lot of tutorials these days in the help file. Also, by the way, the mesh is just done, I think. There it is, right? You can see how it knows to refine it there. Also, going back to your question, there's PTC knowledge base, has a lot of articles. There's like central resources page in the ptc.com website that gives you some additional information. That will also help. And in the help file, they do have some validation guides or verification guides. I would strongly encourage you to try out those. The verification guides are using problems, and they would some designs, and they would compare it against theory and Ansys or Nastran or some other tool. So they really kind of helping you, giving you that confidence that results out of Creo are indeed valid and they are comparable to the other codes out there. So that's another thing I would use, right? So yeah, but yeah, I can show us. Yeah, sure. Yeah, we can absolutely. We'll show the verification guide as soon as I know we're almost running out of time here, but I'll quickly show you that towards the end as to where to access those verification guides. Those definitely help. Okay, very good. Let's see if there's any other questions. Okay, so going back here, right? I've done the mesh in here. I've done my constraints and loads and everything. Now it's just a matter of running the results or running the analysis, right? So I'm going to go run, and it's doing its, as you can see here, open the Creo Process Manager, and it's working on it. It's solving it here. So maybe while it's solving, let me quickly go through the help. So as you can see here, if you click on this little question mark in Creo, right, regardless of what release of Creo you are in, it should take you to a help page. I already have it kind of open here, so let me just kind of give you, I'll open up in my second monitor real quick here. I'll just pull it up here so you can see it. So when you go to the home page of your help, this is kind of how it'll look like, right? It'll have Creo 7 or 6 or 5, what have you, what's new, some tutorials, right? There are several tutorials these days, but specific to simulation, right? If you go to simulation, all the way at the bottom here, right? As you can see, there's quite a lot of options now, right? The Creo Simulation Live that I was talking about, both Ansys, Ansys products are listed. These two are those. The old Creo Simulate from PTC, that's still there. They all have, as you can see, verification models. And if you see additional information, or if you see, there it is, right? Creo Simulation, verification overview. So what does this do? Verification guide, really, right? So results are compared to those obtained using traditional codes, Ansys, Nastran, NAFEMS, or theory, right? You can even, when you install the help, remember to make sure that when you install Creo Simulate, to ensure that it also loads these files, but it has several examples here. So if I go to static analysis, there are quite a few examples here, right? Like a cantilever beam, axisymmetric cylindrical shell. If I go to the cantilever beam, for example, looks like they're compared it against Nastran, Roark, and Young. So you got, and it kind of gives you, right? Theory comes with this value. Nastran structure comes with this. That is Creo Simulate structure. There's percentage difference. We use polynomial. It's a P code versus a H code. It gives you all that information. So it's something that, this is what I was mentioning when you asked me about what tools you could use to get kind of, initially you might want to try this out. That'll help. And obviously your work designs too, right? You have to start getting the confidence of accuracy and things like that. So that's there for all of them, right? So there's a verification guide, even Creo ANSYS, a simulation live, there's like a simulation verification models, what graphics card they used, etc. Right? That's all in the help file there, right? So, okay, so it looks like this is almost done, I'm thinking. There it is. It's just, let me go back to my results here. So I got, there it is, just got done, right on time, perfect timing there. And if I go to von Mises stress, and if I say display the results, there it is. I could show with my mesh. I could do the little play and maybe increase this the animation speed a bit here. So you see what we're doing. We constrained it at this end, and then we kind of added, we did a moment load, and you could see what's going on here. And with those joins, I'm able to control that behavior too, right? The degrees of freedom behavior there. Now, I know I could do this with, for example, deflection, right? There's your deflection plot in here. And you can change the unit system, all that legend values, and you can change the legend values, show the minimum, maximum, things like that. But what if I'm interested in, for example, I just want to show the results in specific regions. For example, I could just go and say, I want to have a contour plot of not the entire assembly. I'm going to remove this and maybe just pick up a body or a component and say, of this part alone, von Mises stress, or even principal stress, things like that. Let's say von Mises stress, it's ductile, so just going to want to look for von Mises stress here. And as you can see here, it kind of, whenever you create a new result, it kind of tells you it's out of date, and you can always go update results in there. So it kind of retrieves it from the solution, the results that we are looking for. You can also use like I could have just selected a plane or a face. It would just give me results for that specific face. I'm essentially isolating specific components of interest in this case, right? That's really what I'm doing here. There it is. Okay, so let's say I go back to this one here and say, I want to show the results. There it is, right? I'm just looking at the results of that part alone here, right? That's really what I'm looking for here. And there it is, right? I might want to add some probes, right? I can add simulation probe, and I can see what is a stress at that point or this point, things like that right there, right? I can have it calculated that too if I have to, right? So maybe cancel out of that. Or I might want to go say I want to add some additional ones in here. So maybe I'm just going to go select one of my datum planes in Creo, right? Maybe this datum plane, right, goes to the middle. I'm thinking right there. And that's where I would like to show the von Mises stress. And maybe again, update my results here. So yeah, in fact, instead of doing this every time, I could just save this as a template, and you could also view results from template. Very, very, very useful tool actually. So that each time you're not doing this manually, and you run the analysis and then say show results from a template that kind of always loads the things that you want, right? So that's another option there, right? So if I go to my results here, I could just go say results as a template, right? I could also define results from template right in here. And so now if I go to that third one and look at, see how I'm just looking, I can just say turn off the mesh for now, but I'm just looking at that geometry inside there, right? So now once you're done with results and everything, you have the option to do a file, do a save as. And you can save this, or you can archive your simulation data as an APR file. And if you have Windchill, I mean, from 12.0.1.0, the latest Windchill release, that can also be managed instead of Windchill. But if not using Windchill, you could put it in a folder, and anybody can open that, and it'll have a backup file, and you can view the results, etc. Right? So if I want to look at results of some other assembly here, so let's say that's something I've already done. I just erase everything from my memory from the Creo session here. And if I go to, let's see here, if I open up, there's a folder where I'd run an analysis on an assembly, and there is my APR file, right? I just open that APR file, and what the system does is, yeah, we'll just open up an existing one in here. It's going to extract the backup file, as you can see here, right? It has pulled up, I had some probes done in there. It's part of that bike assembly there. And as you can see, it's currently loading those results. So you do have the option to just save it out as an APR file, and anybody can open that APR file, view the results, do their reporting, etc. Right? So, okay, so that's another option there. So let me just go back to while we're waiting on this, I'm going to go back to my the presentation here. You might be wondering, okay, so we at PTC and TriStar, we do a lot of webinars almost every month or every other week on different products that we support, whether it's PLM or CAD or FEA. If you would like to view the recordings, you can either go to our YouTube channel or just go to tristar.com, and there you will see the resources, right? Under resources, you will have a webinar replay. You can go there, right? Or you can just go to our YouTube channel as well. So let me see if there's any other questions, as we are, I know we're way out of time here, but let's just see if there's any other questions. Okay, I don't think, yeah, if you have any questions, feel free to type them in the questions area. Okay, looks like right now there's, yeah, and let me just see if it loaded these results yet. It's still loading, so we'll continue with this in here. We'll just to kind of wrap up. Before we wrap up here, just wanted to remind you once again about the time-limited offers that we are running this promotion through end of December. It's specifically on the Creo Simulation extensions, both the Ansys based as well as the Creo PTC's own Creo Simulate extensions, right? 33% off on that. If you need to know more information about it, please reach out to your account reps at TriStar or visit tristar.com. Yeah, if you have any questions, feel free to contact us anytime at tristar.com or call us at 800-800-1714. So I hope it was informative, and hopefully you got an overview on the new Creo ANSYS product introduced in Creo 7, and an overview on the simulation tools instead of Creo. Currently, we thank you for spending your time in this webinar, and you all have a great rest of the day. We look forward to seeing you soon in another webinar. Thanks.